Hey, Coach Reeves here, and today we're going to start quadratics. Now, quadratics are going to be very similar to absolute value, but there'll be a couple of differences, and I'll have to show you what those are, okay? But for the most part, everything's going to be the same as far as transformations, okay? We can reflect over the x-axis, so it would open down. We could shift it up, we could shift it down, we can shift things to the right, we can shift it to the left. We can stretch them vertically and make it skinny, or we can vertically compress them to where it gets flatter or wider, okay? So let me show you what I'm talking about. We're gonna graph the parent function. All right, so this is our parent function of y equals x squared, okay? So we're gonna pick some values. We're gonna substitute in these values, and we're gonna say that 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared. Negative 1 times negative 1 is a positive 1. Negative 2 times negative 2 is a positive 4. Now, if we plot these points, we would look at something that looks like this. We'd be at 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And when I connected those, that's what my graph of my parent function would look like, okay? It's not a V-shaped, it's gonna be more of a U, it's a parabola, okay? And again, we can do the same transformations. But one important point that I really you need to make sure that you lock in on is I need you to understand that when you start, you memorize the pattern of 1 squared is 1, 2 squared is 4, 1, 1, 2, 4, 1, 1, 2, 4, 1, 1, 2, 4. You're going to hear me say that a bunch. You need to memorize the pattern of 1, 1, 2, 4. Because later on, we're going to need that pattern of 1, 1, 2, 4 to determine if our graph is a stretch or a compression, okay? All right, so let's talk about this parent function and some transformations. You still have a negative sign in the front. That still means that you have a vertical reflection. We're still going to look at our A value. Our A value, if A is bigger than 1, meaning like 2, 3, 4, whatever, if A is greater than 1, we're going to have a vertical stretch, and my graph, my U, my parabola, will get skinnier. If my A value is less than 1, 1/2, 1/4, 1/8, that means we're going to have a vertical compression. We're going to get flatter or wider, just like normal, okay? Instead of absolute value, we have parentheses. But inside our parentheses, we are still thinking opposite, all right? So if we go to the right, that's going to be a minus something. If we go to the left, that's going to be a plus something, okay? And the back end is the back end. It's our K value, and it's going to tell us if we shift up or down, okay? So look at this problem. They're going to ask you, they're giving you this equation. This equation is what we call, it's in vertex form. Because I can look at that problem and tell you exactly what the vertex is, okay? So, they're going to ask me for the vertex, okay? This number, off of that formula of y equals a x minus h squared plus k. The vertex is going to be what we call your hk value. Your vertex is going to be an ordered pair, and it's your hk. So look what it says. I want the opposite of h and your k. I want the opposite of h and your k value. Or remember, inside the parentheses, we've always taken the opposite anyway. Okay? So look at this. Look at your problem. I have a plus 3. What is the opposite of 3? The opposite of 3 is a negative 3. And then my back number, my k value, is a negative 6 or a minus 6. This is our vertex. So all you're doing is taking the opposite and then keeping that the same. Remember, inside the parentheses, we're thinking opposite. Okay? They're going to ask you, which way is this graph going to open up? Well, because I have because of this negative in the front, that tells me I have a vertical reflection. My graph is going to open downward. So I know my graph is going to open downward. That means this is the location, that's the location of my vertex, the tippy top, okay? If my graph opens downward, this top point is going to be a maximum value or a max value, okay? If my graph were to open upward, meaning that this was positive, if this was positive, my vertex would be down here at this low point, and this would be a minimum value. Now these are terms you probably learned in Algebra 1, but we're just going to make sure that you understand those, okay? So they're going to ask you, are you going to have a minimum or a maximum value? Well, we're going to open downward, so we're going to have a max value. So I'll come over here and I'm going to say, hey coach, I have a maximum value. And what is my maximum value? Well, max is going to be the y value of your vertex. So if I look at my vertex, this is I know it's called an H and K, but this is also thought about as an X and Y location. So it's going to be this value right here, and you're going to tell me that my max value is going to be at -6. Max value is going to be at -6. They're going to ask you for my axis of symmetry. The axis of symmetry is the imaginary or invisible line. It is a line, but it's the line that splits the parabola in half. It goes right down the middle of the vertex, right down the middle of the graph. This is your axis of symmetry. And it's a line, so we write it as an equation of a line. You can't just write a number, it's a line, so you have to say x equals. So it says going to be x equals, what number's in the x location? -3. So you would tell me my axis of symmetry is going to be x equals, and this -3 is in the x spot. So once you find the vertex, you have actually found two more things. You have found your maximum or your minimum value, and then you use this to find your axis of symmetry. You find the vertex, you have found the max or the min, and you have found the axis of symmetry. Now we're going to hold off on the X-Intercepts just yet, so we're going to do that on the calculator. I'm going to show you how to do it. But right now we're going to list our transformations. And what do our transformations look like? Well, I have this negative, so that tells me that I'm going to have a vertical reflection. I have my A value. My A value is less than 1. It's 1/2. So that tells me that I'm going to have a vertical compression by a factor of 1/2. Then inside the parentheses, we're still thinking opposite. So since this is +3, we're going to have a horizontal shift. In this case, we're going to go left 3. And then we look at our K value at the back end. Our K value is a -6, so that tells us we will have a vertical shift. It's a -6, so we're going to go down 6. Now these are the same transformations that we used when we dealt with absolute value. So this should be just a refresher, okay? All right, so now we have found everything except we need to determine the X-intercepts. Right now we're going to be nice to you. We're going to show you how to do it easily on the calculator. All right, so watch this. When I go to the calculator, here's my equation, okay? I'm going to put this in and I need to graph this. So I'm going to say a -1 divided by 2x. All right, let's go delete that. Let's put this in parentheses. A -1/2 parentheses x plus 3 divided get outside your parentheses, or you can close your parentheses. We need to square it. So I have squared, and then we go minus 6, and we hit enter. Now, look at my graph. My graph is way down here. It doesn't touch the x-axis. So what does that mean? If my graph never touches the x-axis, then I will not have x-intercepts. X-intercepts means where does the graph intercept or touch the x-axis? My graph is way down here at -6, and it's opening downward. It's going away from the x-axis. It never touches it. So when we go back here to our problem, when it says x-intercepts, we would write none on this problem. Okay? All right, let's try one more. Okay, so we have this equation. So they're going to ask us for the vertex. But look at this situation. All I have is an x inside the parentheses. So what this means is x minus 0 squared. Because x minus 0 is just x, and that's x squared. So this is the same thing as this. Okay? So we have x minus 0 squared minus 5. We said we could find the vertex. We could find the vertex by taking the opposite of this number, and then this also the back value, our k value. All right? Well, you can't take the opposite of zeros because zero is not positive or negative. So this is just going to get me a 0, -5. There's my vertex. Now that we have found our vertex, I told you we have now found two other things. What have we found? We have found our max or a min. Well, in this case, this is a +2. Look right here at the front. That's a +2, which means my graph opens up. My graph is going to open up. My vertex will be way down here. And if it's at the bottom, that means it is a minimum value. This is a minimum value. And what is that value? My minimum value is a -5. It is the k value, or it's in the y spot. So we're going to say the minimum is going to be -5. Now the axis of symmetry. The axis of symmetry is this line that splits it, goes right down through the vertex. It is a vertical line, which means it's going to be x equals some number. In our case, we're going to say that x equals what? What number is in the x spot? The 0. There is our axis of symmetry. Now we're going to list our transformations. And remember, as transformations go, if it doesn't change from the parent function, then we don't talk about it, we don't list it as a transformation. All right, so what do we have? I have a 2 in front. That 2, this 2 right here, is bigger than 1, so this tells me that we will have a vertical stretch, because it's bigger than 1. We're going to have a vertical stretch by 2. Over here, inside the parentheses, there wasn't anything that I could take the opposite of. So that means we did not shift left or right. We did not have a horizontal stretch, a horizontal shift. We didn't shift either way. So the only other thing we have is a -5. And that -5 is going to get us a vertical shift down 5. Okay? That's a vertical shift down 5. Got it? All right, so now we're going to try to graph it because we're going to find our x-intercepts. Okay? So we go back to the calculator. Going to go to a graph, and we're going to put in our equation. And we're going to say 2, and then we're going to say parentheses, or you can just put x squared if you want to. You can say x squared. You don't need the parentheses. And then we're going to say -5. -5. And we're going to hit enter. And this is my graph. Okay? Now, where do we touch the x-axis? Okay? We touch the x-axis right here and here. It's going to be between -1 and -2. But I don't want you to guess. I don't want you to estimate. I'm going to teach you how to use the calculator. Okay? So we're going to say menu. We're going to ask you to, there's two ways to do this. I'll show you one way. The first way is to hit trace. We're going to hit trace and we're going to go graph trace. Menu, trace, graph trace. We'll write this for you. Okay? Menu, trace, graph trace. Our cursor is down here. We can move the cursor by pushing our buttons. And look what it says. It says our 0. This is our 0. And that's where it touches the x-axis. The x-intercept is also known as a 0. It's also known as a solution. It's also known as a root. In second semester, you will hear us use all those terms about, hey, what's the x-intercept known as? A 0, a solution, or a root. Okay? All right, so look what it says. It says I'm located at -1.5. Look what it says. It says I'm at -1.5, comma, and it says -1.2e, -1.2e to the -12. Now we know that this should be the number 0. So I don't want you to panic or freak out. Oh my God, what does that mean? This is scientific notation. When it comes up with an E, that means scientific notation. And that means we would move our decimal point 12 times to the left. All right? But even though we're going to move this 12 times to the left, you're going to get a bunch of zeros, 0.11 zeros. Here's the question, and I don't have a true answer for it, but the calculator sometimes will do this instead of just writing the number 0. They tell you that it's a 0, but they give you a number like this in scientific notation with a bunch of zeros. All I want you to do is, if that happens for you, is just to treat it as the number 0, okay? So you're going to treat this as the number 0, so we're going to say, hey, this is the same thing as -1.58, comma 0. That's that x-intercept. But we also have another x-intercept. So we're going to travel. All right, we're going to make our cursor move. And look what this says sometimes. It tells you what the y-intercept is. Sometimes it's going to tell you that it's the vertex. Also, it uses that terminology. And then we keep moving. There is my other 0. Where is my other 0? It's at a positive. This one was at a -1.58. This one is at a positive 1.58, and we're going to say it's at a 0. We're not going to use the 1.2 -12. That's the scientific notation, okay? We're going to use this. This is the location. So on my paper, I would like for you to tell me that my x-intercepts, the x-intercepts are an actual location on your graph. So you need to write it as an ordered pair. So you would come in and tell me, Coach, they're going to be at -1.58, comma 0, and they're going to be at a positive 1.58, comma 0. Those are my x-intercepts, okay? I would prefer you to write it as an ordered pair. Got it? So that's how you use your calculator. Let's go back and look at this again real quick. Menu, trace, graph trace. And that'll probably be the easiest way to find your zeros. Now we will show you another method later on, okay? That'll be in a different Zoom, but I'll show you how to find it using another method, okay? All right, moving forward. Now we have to write our equation. They're going to ask us to write the equation, determine the vertex, axis of symmetry, and the transformations, okay? Look at this guy right real quick. My vertex is right there. Where is the location of that vertex? I'm going to be at 1, 2, 3, 4. I'm going to 4, 5. My vertex is going to be at 5, and I'm down 1, 2, 3, 4, 5. So I'm going to be at 5, negative 5. There is the location of my vertex. Let me move this just a little bit. We're at 5, negative 5. Remember, when you find the vertex, you've also found some other things. And we have found the axis of symmetry. My axis of symmetry will be listed as x equals, what number's in the x spot? 5. Okay? There's my axis of symmetry. My transformations. Well, here's what I'm going to do. We're going to write the equation of this real quick. Okay? We're going to try to determine the equation. Might be tough. We might have to use the calculator, but we'll see what we can do. Okay? We know this is going to be, let me give you some room. We'll go up here. Y equals, that's always a good start. All right? We're opening upward. My graph opens upward. So I do not have a negative, because the negative means you have a reflection and you would open downward. But I'm going to look at my A value. And do you remember what we said about that pattern of 1, 1, 2, 4? Okay, look at my pattern. 1, 1. 1, 1 would put me right here. But my graph isn't right there. It is at 1, instead of 1, 1, it's at 1, 2. So we're twice as high as we normally are. We're supposed to be at 1, 1, but this one is at 1, 2. We're 2 times higher than we need to be. That means we're having a vertical stretch by 2. So that means my A value will be a 2. Okay? Now we have our parentheses squared. What do you put inside the parentheses? Well, remember, we're thinking opposite. We went to the right 5 units. We went to the right 5 units, so that would be x minus 5. Not plus, because we think about the opposite. And then what did we do? We went down 5, so that would give me a minus 5 at the back end. There is my equation. And now that we have our equation, it's easy to list the transformations. What are your transformations? In this case, I would have a vertical stretch by 2. In this case, I would have a horizontal shift. Which way did we go? We went to the right. So we have a horizontal shift, right 5. And then where else did we go? We also went down. We went down 5. So we have a vertical shift. We have a vertical shift. Down 5. Okay? That's how you do that. Let's try this next problem. Let's try number 10. Because the tricky part is writing the equation. Okay? So let's determine where is my vertex. My vertex is right here. It looks like I've gone to the left. 1, 2, 3. I'm at negative 3. My vertex is going to be at negative 3. And I have gone down 1, 2, 3, 4, 5, 6. I have gone down 6. This is the location. Let me move this just a little bit. This is the location of my vertex. I'm going to be at negative 3, negative 6. Right? Now the axis of symmetry, like we've been talking about, the axis of symmetry is this line. And that line is going to be through this x value. So we're going to say that x equals negative 3. There's your axis of symmetry. Okay? So now we're going to write the equation for this. Okay? So we're going to say y equals, my graph is opening upward, so it's going to be positive. It's not going to be negative. But we're going to be here. We're going to go 1, 1. I didn't even make it up to the 1. Instead of going 1, 1, it's about halfway up. I'm not sure. I don't want to guess, but I didn't go 1, 1 and I'm not on the graph. I went 1 and it's about halfway up. So we're going to do another box. We're going to go 2, 4. We're going to see if 2, 4 is there. So we're going to say 1, 2, 1, 2, 3, 4. But it's not there. It's not at 1, 1. And it's not at 2, 4. The graph doesn't go through those points. But look what it does go through. 1, 2, 2. Instead of going 2, 4, it is at 2, 2. And 2 is half of 4. It's half of what it should normally be. So I don't have a stretch, but what I have is a vertical compression, because instead of going 2, 4, I went to 2, 2. Half of what the normal should be. So you're going to tell me that I have a vertical compression by 1/2. And then now we put in the vertex. Go back to your vertex. Remember what we said, we're seeing opposite. The opposite of the -3. Opposite of -3. What would be the opposite of -3? X plus 3. And then what is it? -6. We're down here at a -6. We went down 6. There's my equation. Okay? That'll take a little bit of practice, especially with the pattern of 1, 1, 2, 4. My transformations. Well, I'm going to have a vertical compression by 1/2. I'm going to have a horizontal shift. And this we did, which way we went? We went to the left, or the opposite, we went left 3, and then we also went what? We have a vertical shift down 6. Vertical shift down 6. And there's your transformations. Okay? So it's a little bit different, it's a little bit harder. Okay? Here's the bad news. This is the bad news on this. When we did absolute value, you could count boxes and do slope. If you count boxes and do slope now, you're going to miss it. You're going to miss the A value. Okay? All right. Let's try another problem. All right, so they're going to ask you to write the equation using the transformations. Now we're just going to go backwards. This is what you've already done. We know that the parent function has to look like this guy, but we're going to apply the transformations. What does it say? We have a vertical reflection. What does a vertical reflection mean? We're going to have y equals a negative. That means we have the vertical reflection. It says we have a vertical compression by a factor of 1/5. We just drew a line through it. Of 1/5. So we're going to have 1/5. And then what does it say? We have a horizontal shift left 3. We have a horizontal shift left 3, so we're thinking opposite, so we're going to say x plus 3. Did they tell you this? We have a vertical shift up or down. Did they say anything about going up or down? No, so we do not write it. This would be my final answer. So this is all we're doing. If you have any questions, ask us, email us, show up in the Zoom, tell us what's bothering you, okay? It's going to take a little bit of practice, but it's really not that bad. Hey, good luck.